Welcome to another video on my robotic arm with pneumatic hand with some details. Here you can see the pneumatic compression engine with the actual engine and the compression chamber. Then 5 valves, 2 robo interfaces connected by USB, which you can see right here and right here. Power distributor to power everything. Then the arm, of course, the pneumatic hand, which is powered by this compression. Then wrist motor, base turn motor, pivot as you will, lower pitch engine, hand pitch engine. This one is to move the hand or the arm back and down like this, back and up. Same idea for this hand motor, for lifting the hand like this, but it is too tight right now. And on the other side is a dual motor to make this move. Last time I made a thorough reconstruction, or did a thorough reconstruction of this wrist motor, which didn't end up quite as I liked, but it's the way it is. So let's find out if everything works the way I intended, or as close as. And for that, let's also see the software. So now at the computer with terminal to start my code, obviously the camera, the diagnosis interface and the code. So the idea is to take everything, and last time it worked with the code, but not everything worked with the diagnostics interface. But let's just run every detail and see whatever happens. So, checking. Compression is going, and here I see a problem acting up, which is indeed a real problem, because the motor is trying to hold it while it should release. So this is better. Okay, now I have here a serious issue. I'm tilting the motor, or the hand actually, making sure it releases. But this also shows that the yaw does not work. And I have to assist it. And here I have to investigate what it is, because this hand should be held in a certain way. And I'm doing that with this blue cord, which obviously is not quite helping. Because when it... Oh, that's another point. Okay. Right. So now I'm looking here at the top, and this switch is supposed to hold the wrist like now, and I'm... Nope, that is not good. So I'm stopping it. So I'm forcing it. It's supposed to stop this with this plate here, this switch, so the yaw engine can go. But this switch is never properly dealt with. So that's a problem. And to make that work, I actually should replace this by this type of switch, which is here and which is here. The bipolar switch. No software needed, but on the other hand, is it wise to replace it? Because if I replace it, I will take the software out of it and it just switches the direction of the motor, while the intention is to signal this, and let me use the diagnostics interface for it. And that obviously does not quite work. Slave, does that work? Okay. Where does this one go to? That is this wire. This wire goes right here, and that is indeed the extension number 3. So I should be seeing this, and I don't. So if I now select the other one, and slave, that does work. Alright. So yes, it does work apparently, but not good enough. Also, this has been taken too tight, which is caused by the hand being in the wrong position. Oops. More things to solve. Right, after some thinking, a bipolar switch is, bipolar switch, let's call it that way, is not the best. However, this is not very smart either, not the best solution, let's keep it that way. I have manually released this cord, and then it turns out that if I do it like this, you can immediately, or should see, yeah, now you see that input 3 right here is burning and keeps on burning. This cord is now going sideways from the winch, which is not ideal, but it's the way it is. Then the other thing is, if in this position the hand leans to this way, to this side. In any other position it doesn't quite work that way, so I move it this way, and it will never, despite any position of this one, it will never touch this switch, and that means that it will be pulling. So either way, I have to prevent that this the disc ball is getting further than this point. Now I can put a plate here, but you can see that the hand is moving, but this switch isn't. So the best way to do it is put another switch on the other side. And let me see if I can change the position of the camera a bit, which might explain a little bit better. So right here we are, and making sure that the camera doesn't tilt. So this is the way the hand evolves around the wrist. This is a switch that you hear, and once again input 3 is not being activated, and upon clicking the switch it already turns the other way. Now it's working, now it's not. Going the other way, another one, and once again the switch is not being touched. Okay, moving the switch further. Now it is. So once again. So this is the best situation. However, when it's this way, the hand automatically goes there, and this switch will never be activated. So I need the same construction right here, which doesn't make it any easier. So does this solve the whole problem? No, because now I am talking about the sheer weight of the hand, and not even this motor is activated. Motor with gear to actually run the winch that is under here, which is operating this blue cord, which is the yaw movement. Is that another problem? I'm afraid so. So how to deal with that is, I'm afraid, quite a different question. But how to do it? That's a major reconstruction. So with this analysis of a malfunctioning or not quite as desired functioning wrist and hand position, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Please leave a comment or suggestion, very much appreciated. You can also follow me via Twitter and Instagram. And please show support by becoming a patron. If you don't want that, then you can also donate via either PayPal or IBAN. So next time, some reconstructions over here. For now, take care, have a good day, stay safe. Bye bye.